Hello and welcome to this composition analysis show and tell. Today we are going to be talking about criticality score and dependencies. 1 second, let me just share my screen. Is my screen is shared, right? Yeah, okay. And then just one more, I'm going to try to go into presentation mode and see what happens. Does it continue to be shared? Yes?
Yeah.
Okay, I probably should have done this before we start recording, but anyways, so we're good. Okay, so I'm going to talk about the open source security foundation criticality score project. So first I'll get into OSSF a little bit. So it's a fairly new thing. It started in 2020. It's a collaboration between a bunch of companies, like really big tech companies like Google, Microsoft, and others, and the Linux Foundation. And the idea there is basically, everyone understands the critical nature of open source to everyone else's project. But in the meantime, there's not really an endeavor to secure them, right? So that's basically kind of the reason to be of these of this group. And inside of this group, there's several working groups, and they're based kind of on different things like security threats, digital identity. The groups whose projects we're going to be looking on at today is the one kind of working on securing critical projects. And it has this concept called a criticality score, which I was interested in. And I thought that it could be useful for our team. So this is like a famous drawing. I think everyone's seen it. It's like basically like XBCD, that a lot of what we think are amazing, awesome projects have so many hidden dependencies that, you have this, you only need like this one like piece to fall down to make the whole project fall down, as we've seen with supply chain attacks and critical vulnerabilities at like really low levels like OpenSSL and stuff. So this kind of the understanding for this project is to figure out what are those critical projects, what are those critical the projects, so that there are limited resources that even these companies have to support them, right? To pay their developers to work on it, or to pay the maintainers to work on it, or give time to whoever. So you got to identify the most critical and work sort of your way down. That's kind of the concept. I think there's a recent example that we've all kind of heard about because it even affected GitLab. It was the Ruby My Magic gem that the maintainer released under MIT license, and then the maintainer of the gem that the maintainer relied on was shared MIME-info, which was released under GPL v2. And so he basically told the maintainer, you should take it down, or you should change your license. And I think the developer in the peak of kind of, maybe, well, I'm not going to judge why he did it, but basically he just in like, he took down the gem and he archived it, which affected, something like 500,000 repositories, but really 172 other packages, including something we relied on at GitLab. And so there was like there was that day was like, panic for everyone who relied on this gem to try to like get around it or figure out how they can make it work. So that was an example of that. So there is a security. This is not necessarily a security component. It just demonstrates how a critical project affected like so many downstream repositories and projects and companies. So what's the criticality score intro? The criticality intro is used to identify these key open source projects. And it's kind of, the idea is to create an objective, repeatable rating. So I think we all know, like, let's say, even for yourself, if you're gonna install a project on your own machine, like let's say from GitHub, let's say there's 5 different ones, you're gonna probably take a look at, stars, forks. You're gonna look at how old it is. You're gonna look at, maybe who the maintainers are. But that's kind of a qualitative feel that you get, right? You're like, okay, this project looks better than this one. and this is meant to quantify that feeling, I guess, quantify the idea of what is a like a critical project that people can rely on. And again, the interest is to disperse kind of the maintenance resources available for these key projects. So, starting from the top, I guess. And again, it's a pretty straightforward formula. It's basically you have several parameters for rating, and then you have a weight for each parameter and a threshold, which basically just makes sure that some of these parameters don't run away from us in case like they weigh too heavily. So these are the current ones. So things like just kind of to give you an intuitive understanding, it's created, updated. This is for the project, how many contributors there are, how many organizations support it or use it, the commit frequency, recent releases, closed issues, updated issues, dependence count. So the commit frequency and the dependence count is a very interesting one. It's the one that basically indicates how many other projects depend on it, right? And I think that's weighed sort of heavily. So there's like in this project has released the top 200 critical projects for like 10 or so frameworks and languages, and a bunch of the modern ones in it. Here's a Ruby top 20, and you can see here it's sorted by criticality score, which is at the rightmost column, and it just shows kind of the other parameters, which I squished a little bit because just to show how kind of rates. And yeah, you can see at the top, like, Rails is obviously the top one, but then there's things that maybe, are not so noticeable, that maybe you're including Spree or something, or I guess these top ones probably are understood to be critical, but then as you go further down the list, it gives you a good understanding of kind of the ecosystem for Ruby, and then for Go and other things that we rely on. So the reason I wanted to, I guess, so that was the presentation of the criticality score, and the usefulness to the working group is just to identify, currently the current point of it is to identify open source projects to support and identify ones that to the community, which ones are critical, so you understand kind of the maintenance burden that you should kind of focus on. The reason I want to present in composition analysis, and sorry, and if you want to stop me at any time, just go ahead. The reason I want to present this for composition analysis is because I think that there's a component here that could help us also identify dependencies. So with an addition of other factors, we can actually kind of create something like a dependency risk score for the dependencies in the project, right? And that would give us sort of another signal that's kind of continuous, that would allow us to sort of judge between projects. Like, even though some project has a much more critical bug, but if it's not in the path of if it's not in the path of criticality, we can focus on a different project. It allows triage and all sorts of things, and I'll get some use cases that I think are useful. But then, so what I think is useful to kind of to maybe add the security layer for us to assess something like time since maintainer was on project. And I have to thank Nicole, because I had a conversation with her about some of these things, and it was helpful to understand how she thinks about it. Nicole's our product manager for composition analysis. And so things like time since maintainer was on project, number of maintainers, historical number of vulnerabilities, and severity score of historical vulnerability. This is just some thoughts I have, right? So time since maintainer was on project, why would that be useful? Well, if it's a new maintainer, one, there's a maintainer trust, but also would that maintainer be able to fix a security issue quickly? Does that maintainer understand how the security issue would affect others, right? Number of maintainers is useful, right? Backup, things like that. Again, these are my thoughts on it. I haven't thought it fully through, but something like historical number of vulnerabilities would indicate the overall, I guess, reliability of a project. Maybe, like, is this project something that you can trust if it's critical, if it's in the downstream path for your project? Is that something that, when you're judging whether to update this project or even include it in your dependencies, should it be there? And then the severity score historically, so basically, how vulnerabilities or advisories, their relative severity over time, and might indicate other things like, is this project kind of insecure, or does it add And there's many other parameters. I just want to kind of demonstrate what will be useful for us. Again, not to rate the criticality or which projects to maintain, but to actually figure out in the dependency tree what the risk factors are of the dependencies. So these are the parameters. I hope that makes sense, because I kind of move between those pretty quickly. Again, ask me questions. So if you need to. So here are some ideas for uses for composition analysis, and what I would like to call this is dependency risk. That was a criticality score. I think the criticality score could be kind of a base in which to build this other thing called dependency risk, another score. So for example, it would add an additional parameter for scoring a vulnerability, right? So not just saying this severity is high and this priority is this, but actually, and you know, CWE parameters are useful too, but it would help us help maintainer or the project owner to in the decision to address sort of equivalent, you know, CWE parameters and equivalent severity, but figure out which one has a higher dependency risk to maybe either to fix it first, to update it first, or to just focus on triage, right? Is this advisory affecting us, right? If it is, if there's two advisories, I want to figure out which one I should focus on first, right? For this, because of dependency risk, relative dependency risk of both or several. The other thing is identifying dependency risk overall of a merge request, right? So this is kind of something that would allow the security department to get involved. It's more of a compliance thing, right? If there's dependency changes in a merge request and their dependency risk passes some stated parameter, you know, this could be delegated to, you know, security maintainers or escalated or require more reviewers. And then historically, we can identify deltas in dependency risk of a particular dependency or a tree of dependencies so that we can learn about the relative danger or risk of a particular part of the tree or dependency in general. And then sort of like over time, see how it, you know, how it affects the project and whether it's worth maintaining or something like that. And then the other thing is sort of like, I think I'll get into it, but dependency risk changes, I think, much more often, or sort of the dependency factors like maintainers, time since commit, all these things change much more often than advisories appear for a project. So this is kind of, I would say, an alert system. It's a smell of a dependency that we can show users earlier than an advisory, that they can kind of get this without anything changing in their project. They can start to see a dependency risk change and assessed. And then again, adding a layer of security compliance, right? So saying like things over a certain risk level require, you know, security department intervention, or you know, basically cannot pass. And then increasing analysis depth, allowing us statistical analysis. Like if we have more historical data, more parameters, we can figure out risky dependencies or truly risky dependencies by looking at these secondary factors. I think I'll talk about it a little more, but let me just get into an example here. So this is an example of dependency risk in an MR. So here's our project. It's fairly simple. It's got these first layer of dependencies, and then you've got these you know, 3 dependencies that rely on dependency 3. You can see the risk scores here. So I'm like, you know, I'm just playing around. There's no such risk score really, but you can see they're fairly low, right? But let's say we add a new dependency on which 3 relies on, right? And this one has a very high one. So our score is 0 to 1, right? So this is 80 or 0.8. So now all of a sudden we've introduced a high-risk dependency. There's no advisories, there's no vulnerabilities, it's just a high-risk dependency for whatever reason. And you know, we can maybe, I'm just kind of thinking of a use case for users of GitLab. You know, we can even justify like, here's why we think this has a high-risk score. But you can see how it affects risk, because now the dependencies 3 has become a lot more risky, and the dependence and the risk has cascaded up to all the dependencies that are including it. And so from here, a lot of things become possible. For example, if that dependency has a competing, if that project has another one that you can consider, you can switch to that project, right? And you can assess the risk of that. So a lot more things become possible than just looking at vulnerabilities. To me, vulnerability is like a yes or no signal, 1 or 0. Does it exist? Is there an advisor or is there not? And until there's an advisory, we can't really do anything about a project. Risk gives us a continuum of response that we can do. So that's kind of, I guess, an example of, I hope I didn't go fast, or if any questions, I'll just pause for like 2 seconds.
Oh, it's okay.
Okay, just making sure I don't want to go through it too fast. Okay, so and yeah, I'm just trying to make our time not go over time too much. And hopefully, if there's a lot of interest, we can get into more some of these use cases or discuss more about the kind of the decisions that the working group works with to make some of these changes. And so some other use cases. So we talked to identify deltas and dependency risk. So basically, as we said, changes in parameters such as maintainer count, project staleness, they change, as I said, much more often than advisories come up. So you can think of it as an early warning system. You can think of it as just a total absolute value you can give to a project that if it passes a certain threshold, it needs attention, right? And it gives, users an early warning. We talked about security compliance, right? We can create policies around dependency risk management. I think I talked about that. This is just a reiteration. Scores above a certain level or scores within a certain range require, manager approval, security department approval, or they can't even pass, right? Like if you're highly security conscious, if you're working in a very like locked down kind of project, then you can't even pass a certain risk level, right? So that's the use of a score. And the other one is, I think that's very, very useful is we can increase our analysis depth, or sort of the depth and breadth by making statistical analysis possible. So not static analysis, but statistical, like machine learning. So we can have these secondary factors like learn about sort of how a maintainer behaves on a project, and kind of learn over a history of multiple projects, many projects, and then we can apply it to new projects based on what we've seen, right? Based on kind of a learned, something that we've a score that has been predicted for that particular project. So we can even, for things that don't necessarily have history or don't have like a new project or something that doesn't have a particular depth of parameters, as we saw before, predictive capabilities come in. And then secondarily, other predictive capabilities based on those factors. Like over time, let's say this project with these kind of risk trees, how often does it come up with advisories, right? How often do advisories come up for this project with this kind of tree versus another tree? So that it allows us predictive capabilities to give a lot more intelligence and a lot more early warning to users, which I think is a very useful thing in dependency management. It allows us to be very proactive. So that's kind of the three. So identifying historical data and deltas, and warning users, compliance, and statistical analysis. So obviously there's other things that are possible. I just want to kind of give my thinking about why I think this is useful for the team. So just some references here. I linked the group, I linked the criticality score. There's the paper that led to this from Rob Pike, and just an article on MyMagic. So that's pretty much what I wanted to show, and I wanted to stay within time. So I think we're well in there, and I'll now take questions. Or actually, I will look at second. Okay, so I forgot to share the document again.
Now you need to change the bottom line. Bottom left.
Yeah. I think that's good, right? Okay, so sorry about that. Security team is working on dependency bots. So let me just. Right. Yeah. Oh, they even linked this thing. Awesome. I think I actually saw a mention of it in this issue or a similar issue, but I think this has more details now. So yeah, I think that's there is always a crossover between the kind of the dependency and the vulnerability research team and what we do. I think the benefit here is automation. So yeah, and Olivia, you're saying you want to voice your.
Yeah, just a quick feedback on one of the criteria that we were mentioning. I know this was just rough thought, but this is something also that comes to my mind when we talk about the history of vulnerability that we can see from a given project. This could not always be considered as a bad thing, particularly when comparing straight number with other projects, because some projects are more transparent with the vulnerabilities they are disclosing versus others. So more vulnerabilities might mean more transparency, not necessarily weaker project.
Yeah, I think it's a good point, and I think when I talk about sort of the statistical analysis part, I think what that allows us to do is actually back propagate the risk scores and figure it out. Like, so if the weighting of that should be lower, we can make that lower, right? The benefit of a risk score is it gives us all of these variables in which we can kind of optimize in the space in which we can build a predictive model around. So with enough data, we can do a lot there. So yeah, that's a good point for sure. Sorry, Tatiana, do you want to take?
Yeah, sure. So, and I think that the risk score for dependencies could be a great addition for the dependency scanning list. But yeah, it's kind of like natural, feels like a part of this page, say. But I guess first we need to work on the dependency graph, because we just have like minimal paths for dependency, and we don't have the graph, so we can't just like calculate the score for project dependencies.
Yeah, I think that's absolutely fair. Having a graph gives us a lot more data and a lot more information. Though I would say that just knowing that not having the graph, but just knowing that a project with a high criticality score in the, let's say, gem file log, the locked file, or the the npm log file, is enough for us to maybe show a user to just say, here's this critical dependency path on which you rely, right? Without even knowing about like how it's affected by by the tree, right? I think the tree maybe is more advanced than that, but the capability is there, right? Even now. So that's kind of my but you're right, absolutely. The graph is like a very rich data set, much more useful than just like these scalar values on each project. Olivia, do you want to verbalize?
Yeah, I'm curious if there are known services or API that we can leverage to get those criticality scores, or is this entirely something that we will have to recalculate on our end? I'm assuming that if we want to fine tune some of the criteria and the weights, we might need to recalculate, but some of the data might be difficult to source, like number of maintainers, the history of the project. These are very this is a lot of data. So if we had to source that might take a huge amount of time. So are there any open source initiatives to start building a big database of this information? Like, for instance, we have some known database for licenses information.
Yeah, so I think the same group is working on something called the dependency feed, but I'm not sure. I'm not sure if they're addressing it. This particular scoring criteria, and you can see here that this library that was built. It's kind of I don't know if it's alpha or beta, but you can see here that they rely on your token. So you are pinging the API. So it's kind of in the early stages, but I do imagine it as, if it's proven out the usefulness of this library, then I can see like companies like data sources like GitHub getting onto the train and offering like a feed or some kind of rolled up statistics on these projects without having to kind of do this data intensive querying. But right now I'm not aware of something that gives us an API or does rolling up for us, that does this calculation for us. Oops.
Okay, thanks. Next one is, I think this is emphasizing the needs to have a more modular approach to our dependency analysis. We've already mentioned them multiple times in the past to try to extract the generation of the graph from the the vulnerability analysis and then the license analysis. But I think this is one more additional analysis that we can do on top of an extracted dependency tree or graph. So because I assume this is something that could be done on a different schedule or different frequency than other type of analysis, because it might be more resource consuming and longer analysis, particularly if we have to solve those metadata that I was mentioning. So I think this is a great direction that we're taking for those additional needs.
Yeah. I mean, I think this is a proposal, like not even a proposal. This is a demonstration of what I thought was interesting. This, like I said, this whole kind of foundation was started in 2020. I believe it was like summer last year, maybe even a little bit earlier. So I think it's moving along and it's showing promising kind of ideas. I just want to make sure that as we see something promising to our group, we can kind of look at it and test it out, and maybe even write a project that we can, see how, one, as you say, how data intensive it is, two, how useful it is, right? And how good it is at, for example, predicting the relative insecurity, let's say, of a dependency, or the relative risk of a dependency, and then sort of following those predictions with sort of mapping those predictions to actual events like bugs not being fixed, or security bugs not being fixed, or the number of advisories found against the project. So that could be kind of a step one for us, maybe. Okay, I mean, I think it seems that we are we're kind of out of time and out of questions. So I'm just gonna stop the recording.
Thank you.